Okay, this is lesson 2.7, adding and subtracting rational expressions. Adding and subtracting rational expressions, again, much like adding and subtracting fractions, you do have to make a common denominator. So, how do we do that when it's a rational expression? Well, first step, just like multiplying and dividing, was to factor top and bottom, if necessary. And then step 2, find the lowest common denominator and rewrite the rational expression over a common denominator. And this part becomes the hardest part. This is the hardest part of adding and subtracting rationals, is finding the lowest common denominator and then turning all of the fractions into fractions that have that common denominator. Once you do that, it's not that bad. Then we simplify the numerator by collecting like terms and then state restrictions by determining the zeros of the factored lowest common denominator. Are you ready? Well, doesn't matter, because here we go. Our first one, we don't have letters in the denominator. We just have numbers. So this is kind of a common factoring, or sorry, not a common factoring, a adding and subtracting fractions review. We've got 2x over 3, 3x over 4, and x minus 6. We're adding the first two and subtracting the second one. In order to add and subtract fractions, you need a lowest common denominator. So what is our lowest common denominator? Well, between 3, 4, and 6, 12 would be the lowest common denominator. How do we make these fractions over 12? Well, we look at each fraction and we multiply top and bottom by what would make the bottom 12. So in the first one, what would make the bottom 12 is multiplying by 4. So we're going to multiply the top and bottom by 4. So we got 2x times 4 over 3 times 4. I'm going to show my work for this. This fraction would need to be multiplied by 3 to make the bottom 12. So we got 3x times 3 over 4 times 3. You don't have to show your work like this. I'm just showing so when you look back at this, it kind of makes some sense. To make this fraction over 12, multiply by 2. So x times 2 and 6 times 2. Notice what we multiplied each fraction by wasn't the same thing. It was with the goal of making the denominators the same. So now if I simplify, we get 8x over 12, 9x over 12, and 2x over 12. And once we got a common denominator, all we can do is add and subtract the numerators over the common denominator 12. So these are all over 12, so we can write one big fraction, 12 on the bottom, and we got 8x plus 9x, sign in between tells you what goes between the terms, minus 2x. And now we can collect our like terms. 8 plus 9 is 17, minus 2 is 15, so we end up with 15x over 12. And then we look to see if there's anything common that we can divide away. Well, we can reduce this fraction because we can divide top and bottom by 3. If we divide the top by 3 and the bottom by 3, we end up with 5x over 4. And that ends up being our final answer. We looked for any restrictions, but there was no variables in the denominators, so there are no restrictions on this rational expression. Let's try one where there are letters in the denominator. We've got 2 over ab squared and 4 over a squared b. Well, the denominators aren't the same because in this one b is squared and in this one's a squared. So we need to think about how we can multiply to make the same denominators. And what we could do is we could aim for a denominator of a squared b squared. And the reason why is because, well, if we multiply this denominator and numerator by a, we get a squared b squared. And if we multiply this fraction by b, top and bottom by b, we get a squared b squared. So you're aiming for things you can multiply to get. And we're going to review on the bottom how to get common denominators and what to look for. But basically, when you have multiple letters being multiplied, the lowest common denominator will have the largest exponent on each letter. So this a and a squared is biggest, so we used a squared. B squared and b squared's biggest, so we used b. It's because you can't reduce a denominator. Well, you could, but we're not going to reduce denominators to end up getting to the same spot. That would overcomplicate the question. We're usually multiplying to get a common denominator. So in this case, a squared b squared is what we're aiming for. So what do? Well, we make that common denominator. Multiply top and bottom of the first one by a, we get 2a over a squared b squared. And if we multiply the second one, top and bottom, by b, we get 4b over a squared b squared. Now we have a common denominator, so we can write over the common denominator a squared b squared and add the top, 2a plus 4b. If these were like terms, we could add them together. They're not, so we can't. There is a common factor of 2, and if there was a 2 common factor on the bottom, we could divide it away, but there's not, so we can actually leave it where it is. However, in this case, there are restrictions. So let's go look for those restrictions. In the bottom, we have two letters, a squared and b squared. If we made a 0, the whole denominator would be 0. We can't have that, so that's a restriction. If we made b 0, the whole bottom again would be 0. We can't have that, so b can't be 0. So our restrictions, I'm going to write them below because I'm kind of out of room, are a can't be 0 and b can't be 0. All right. Let's try one that looks more like the ones you're maybe going to see a lot of. C and D. So with C, we are going to need to do some factoring first because we do have a polynomial expression in the denominator that is factorable because that's a simple trinomial, and here's a binomial which we can also factor. So we're actually going to use the first step this time, factor. If I factor the denominator, numbers that multiply to 9 and add to -6 would be -3 and -3. So we end up with x minus 3 and x minus 3. You could write it as x minus 3 squared. Sometimes it's nice to write it out like this so you can see that there are two x minus 3's, and when you divide them away it kind of makes it simpler, but it's up to you. You'll decide as you do some of these examples. And if we factor the bottom, or the next one, there's a common factor of x, and that would leave us with x squared minus 9, which is the difference of squares. And if we factor the difference of squares, we get x minus 3 and x plus 3. So what do we have here? Well, we have a denominator that has x minus 3 and x minus 3 in one factor, or in one fraction, and we have x minus 3, x plus 3, and x in the other fraction. So our lowest common denominator is actually going to be quite complicated here because we're missing some of the factors that are in this one. So we need to multiply to get them as a part of this fraction as well. And that sounds complicated, but let me show you what I mean. Our first fraction has two factors, x minus 3 and x minus 3. It's missing a factor of x, and it's missing a factor of x plus 3. So that's what we need to multiply in, on top and bottom, to make a lowest common denominator. I'm going to write it up here, of x minus 3 squared, I'll call it squared because there's two of them, and x plus 3 and x. This is going to become our lowest common denominator. We need two x minus 3 terms, we need an x, and we need an x plus 3 because it's a part of this fraction. And we can't take it out of that fraction, so we have to multiply it into the other fraction. So again, this fraction is missing the x and the x plus 3, so we're going to multiply the top and bottom by x and x plus 3. So the top 1 times x and x plus 3 would look like x times x plus 3. And on the bottom, it would look like x. These two x minus 3's make x minus 3 squared and x plus 3. I'll use my highlighter to show you what I changed. What I changed was x plus 3 and x minus 3 on top. Sorry, x and x plus 3 on top, and x plus 3 on the bottom. I multiplied them in on top and bottom. That's all I changed, and it was so we could build a common denominator. So what's the second fraction missing? Well, it's already got an x term, it's already got an x minus 3 term, and it's already got an x plus 3 term. It's just missing the second x minus 3 term. So we're going to multiply the top and bottom by x minus 3. We get x minus 3 on top, and x on the bottom, x minus 3 squared, because now there's two of them, and x plus 3. And here we go. What did I do? I added an x minus 3 to the top and the bottom. And by added, I mean multiplied it in. I multiplied it in on top and bottom. All right. Now, what can we do? Well, we can write it over one common denominator. And that common denominator would be x minus 3 squared, x plus 3. And on the top, we've got x times x plus 3 minus x minus 3. And now we've created one fraction. Now we can look for restrictions. And we look for restrictions on each term in our denominator. So what do we got? Let's use some logic here. X can't be 0 from this x term, 3 from this bracket, or that factor, and negative 3 from our last factor. And there we've successfully subtracted two rational terms. There's another example D. I'll get you to try that one on your own. You can pause the video and try it now, or you can try it at the end of the lesson. What I want to do now is just kind of go over one more time how to find lowest common denominator, because that's the tricky part. So basically there's three scenarios. The lowest common denominator is either going to be one of the denominators, the product of the denominators, so multiplying the two together, or neither, some combination. So what do you mean by one of the denominators? Well, if we had these three terms, 1 over ab squared, 1 over a squared b squared, and 1 over a squared b. The lowest common denominator in this case would have the biggest exponent on each of the letters. So we've got a squared, and a squared. A squared is the biggest exponent. B squared, and b. B squared is the biggest exponent. So it's actually this denominator. A squared, b squared is the biggest. A squared is the largest power of A, and b squared is the largest power of b. That's how we can decide. So when it's just letters with exponents and they're all multiplied, you look for the largest exponent on each letter. If you factored and you have different factors in both denominators, the lowest common denominator will be the product of the two denominators. And what's that mean? That simply means multiply them together. 2p plus q and p minus 2q. No common factors. Multiply both. If there are common factors, like the last example we did, x minus 3 squared, there's an x minus 3 term here. That x minus 3 term is common. So you're not just going to multiply both factors, because you'll end up with 3x minus 3 terms. You don't need that, because this one already has one. You're going to make a combination. So you take the factors that are not in one and you put them in the other. So squared is the biggest exponent on the x minus 3. So x minus 3 squared becomes part of the lowest common denominator. X is in this denominator, so we multiply it and make it part of it. And x plus 3 is also part of one of the denominators, so we multiply it in as well. And we get this combined. So since we have x minus 3 common to both denominators, we don't simply multiply the denominators. We choose wisely. All right, that's it. Thanks for watching, and I'll see you next time.